Well, good evening and welcome to Kopernik Observatory. My name is Drew Desker. I'm the director here at Kopernik, and it's great to have you join us here this evening for our Friday night program. I always do this, and I apologize for those people who have been here before, but just so, who's here for the first time or not since your 4th grade field trip? All right, a very fair number of people. All right. Who here are members? All right, a few more. What I always like to point out is that the people that raise their hand second have a particularly valuable piece of knowledge, and that's the value of a Kopernik membership. We have a family membership that's pretty cost effective, and but what's neat about it is that we belong to what's called the ASTC, Association of Science and Technology Centers, and there are 380 other science centers in the U.S. as well as scattered throughout the world that honor our membership. So if you like this kind of place, you can, a Kopernik membership again is really pretty reasonable, and it gets you into these other places for free. So you could go to this Franklin Institute down in Philly for nothing. You could go down to the Intrepid Museum down in New York City, which has the Enterprise, the space shuttle that was used to do sort of test the gliding for the space shuttles. They have a Concorde down there. You could go to the Museum of Science and Technology up in Syracuse. So if something like that interests you, consider getting a Kopernik membership. So we had just last year finished celebrating our 50th anniversary of being a public observatory and science center here in the Southern Tier. We opened to the public in 1974, and since then we've had literally hundreds of thousands of people and students come through our doors, not only to look at, look through our scopes and learn about the universe, but also learn about science and ecology and geology and electronics. So we are really much more of a we're more than, as I like to say, we're more than 3 telescopes on the top of a hill. But tonight we are going to focus on those 3 telescopes, and but I would like to just point out a couple things to you here. Again, our website always we keep up to date every week, so we always tell you what's coming up. So tonight's our program is on summer skies. One of the things that we also do is we have a very extensive summer camp for youth, for youth that are currently in 1st grade or maybe just finished 1st grade today and going into 2nd grade up through high school. And these are week-long summer camps on a wide range of topics, and they're day camps that so you can, if you get a child or a grandchild that might be interested in this, check out our website on that. But one of the things that I really enjoy doing are these Friday night programs. It's an opportunity for us to learn something new, something outside of what we normally would do. And again, it's not always about astronomy, although again today is in fact about that. But one of the things that we've been doing lately is, well, actually since 2020, when COVID hit, is we started live streaming these programs. And so we have a YouTube channel that is free. You can go to it for free, and what's great about it is that we actually list any of the programs that we have here, you can watch at your convenience. So last week we had one on beginning telescopes. The week before that, the history of Planet X. We had a topic. We had a talk about the Galapagos Islands. We had a couple of high schools. So the back-to-back robotic teams that work in different areas of robotics, talking about their competition robots. We had talks about AI. We've had talks about math, and so even if you can't make it, if you can't make it up here, you can watch it live, and you can ask questions through the chat. Or if you're unable to even be, unavailable on a Friday night, you can watch it at your convenience down the road. And what's neat about this, our YouTube channel, is that not only do we do these Friday nights, but also we've done a number of observing sessions. So we have done some eclipses, and that we've done a live cast. In fact, Jenny Cartie, our speaker tonight, back in March we had a lunar eclipse, and she was here for 5 hours doing that, but she'll tell you more about that. We've done also some sort of watch parties. There have been, not everybody knows this, but there are 4 astronauts that grew up in this area. Eileen Collins grew up in Elmira, Dan Bursch here in Vestal, Doug Wheelock in Windsor, and Doug Hurley in Appalachian. And when Doug Hurley and Bob Behnken were the first astronauts to launch on a Falcon 9 rocket, we took the NASA feed and just sort of had a watch party, and people were able to chat and talk back and forth on that. And so anyway, we are now up to nearly 14,000 subscribers, and people literally will be watching from around the world. In fact, one of them, Lindsay, is our is our Australian member here. Lindsay lives in Adelaide, Australia, and she wrote. Going for my morning walk here, I'll see you soon. So the winter solstice will be midday here in Adelaide. So although I'm not sure how much of this is going to be appropriate for Lindsay being in the southern hemisphere, but there will be some content that I'm sure she'll take. So this YouTube channel has been a real opportunity for us to do outreach, and we really enjoy doing it, and it's free. So I think without further ado, I'm going to pass this right over to Jenny to do. I'm trying to think. Is there anything else that I need to? Oh, no, that's right. I was going to say I did talk about the summer camps, and we did actually a couple weeks ago had this was the 16th year we did Rocket Fest, where people would get rocket kits from us, build them. And I think, didn't you guys do it? You built one, right? And you launched it here? 2 Saturdays ago, we launched about 140 rockets over the day. And it got a large percentage of them back. So so that's always well received when that happens. But anyway, these Friday night programs, again, are just an opportunity for us to learn about something that we may not know about, and so we're very fortunate to have a very dedicated education staff, and one of which is Jenny Cartie, who started out actually as a high school intern and now works for us full time. So Jenny, I'm going to turn this over to you, and we'll swap seats. I'll drive the live stream.
All right. Wait for my mic to go up. There it goes. All right. Let me just get the slides loaded up for you here. This one. Perfect. All right, hello everyone. Welcome to Kopernik Observatory and Science Center. We're so happy to have you here tonight on what really should be a clear sky night, which I don't get to say every time we have a skies program like this. Most of the time I'd say like maybe 75% of the time it's cloudy, so we lucked out, I think, this time, and we'll look at some of the weather forecasts too as we learn about the summer skies. But here's a little preview of a major, very large object that you can see in the summer skies. It's one of the, for us here in New York and in our area and at Kopernik, this object, the Milky Way galaxy, is in our southern skies when it gets to its highest point, which looks right into rural Pennsylvania where it's super dark. So we'll be talking more about the Milky Way galaxy. So the things we're going to go over today, we're going to talk about the ABCs of stargazing. And just raise your hand if you've been to a skies program before out of curiosity. Oh, got one person, got a few people here. Okay, perfect. So that'll be some review for you, but I think it's really important to set the scene for how to observe the sky for anyone that's new or needs a refresher on it. So we'll focus on that. Then we have what can we see in the sky? That's the big one. There's lots to see this summer. Planets, stars, galaxies, and more. And then finally, some observing tools you can use at home. All right, so let's focus on the ABCs of stargazing. Starting with A. And these ABCs are going to be a little bit scary sounding to some degree. And A is for angular size and distance. My goal, though, is to bring this down so that it's easy to understand and you can go out even tonight and start using these ABCs. So A is for angular size and distance. And this is a really handy trick you can use to measure out objects in the sky, whether you're measuring them from the horizon, where the ground meets the sky, or in our case, where the trees meet the sky, and where objects are relative to each other, so the distance between objects in the sky. And the handy trick uses your hand to make sense of this. So it gives you, let's see if this will work here. Yeah, just about. It gives you different gestures you can use that give you degree measurements. That's your angular distance. Okay? So we can start with just our pinky. Now, another important step this hasn't described on the screen yet. You can't have your pinky here, right in front of you. Because what happens when you have something closer to your eyes? It's bigger, right, than if you put it out further. Okay, so you can't have it right up close. You have to stretch your arm all the way out with your pinky. And it's at that size you get 1 degree. The width of your pinky is 1 degree across. All right, then you take your 3 fingers, and that's 5 degrees across. Okay, arm stretched all the way out, 5 degrees across in the sky. You can make a fist, and that's 10 degrees across the sky, measuring between objects or measuring from the horizon. And with that one, it's really easy if you were to measure something from the horizon, measuring its altitude, which we'll get to that word in a bit. You can just stack, right? Stack up. So you go 10, 20, 30, 40, and so on. And as you do that too, your arms are going to want to naturally arc in an angle, which is exactly what you want them to do. Because when we measure true altitude from the horizon, that's 0 degrees, and at the top of the sky, that's 90 degrees. So you want your arm to naturally arc up. Okay, and then finally, my grandpa particularly would want me to say this is the hook 'em horns, right? So that's 15 degrees across, and you want to make sure they're stretched out. All right, and then to give you an example, we have the Big Dipper. So tonight, we'll be able to see the Big Dipper out in the sky, and you can try measuring the distance between the 2 stars at the top of the cup here and here. That should be about your fist across. So you can try that tonight. We'll go out together and do some star tours with our laser pointer, so we can actually point things out in the sky. And we can practice that together. Another good example, small example, and this really gives you perspective on how vast the sky is. So the largest object we can see in the sky, there's really 2, regularly, is the moon and the sun. And in the case of the moon and the sun, they're the same size in the sky. That's why we can get solar eclipses. But focusing on the moon, if you stretch your pinky out and put it right on top of the moon is going to be about the size of your pinky nail. So that's about 1/2 degree. And that's the largest singular object in the sky that you can see. So only 1/2 degree across from your horizon, 0 degrees, up to 90 degrees, and then back a full 180 degrees. So the moon's really tiny. The sun's really tiny in the sky. But they can look bigger because they're among the biggest objects that you can spot there. There are things like, we'll actually get later in the presentation, to something like the Andromeda Galaxy, which is even bigger than the moon. But we'll get there. Okay, So that's the handy trick for measuring degrees. And it's really helpful if you've ever stargazed before with a friend. Maybe you were outside and trying to tell someone where something is in the sky. But the problem with that is we suffer there from parallax, where our perspective shifted. So when you point to something in the sky, they're pointing to something else from your perspective. This trick allows you to explain how to find an object more specifically. So you can say, okay, measure from that, maybe the top of that tree, a couple 10 degrees up, and you can start communicating that way. All right, so next up is B is for brightness, and in astronomy we call this magnitude. And we're going to focus on the apparent magnitude, what magnitude looks like to us from here on Earth today. So in astronomy we have this number line that we can map objects onto from brightest to dimmest. And you'll see this doesn't make a lot of sense because these are negative numbers, right? And what's at the farthest side of this negative number line? The sun. The sun is the brightest object in the sky, and yet it's sitting out here at around a -30 on our number line. Well, I'll explain that in a moment. Just bear with me for a sec. So let's keep going on our number line. As we come down this way, at around -12, -13, we have our full moon. And when the moon is out nice and bright, that's the second brightest object we can spot in the sky. Then we get to some planets like Jupiter, sitting at around -3. And then we hit our 0 marker on the number line, and that is Vega, one of the brighter stars out in the sky. And we'll see Vega tonight. Andromeda galaxy, what I mentioned earlier, you can see a galaxy with your eye. And that's coming this summer. We'll be able to see that, and then into the fall. So Andromeda galaxy you can spot with your eye at around a 4 magnitude. And then out here at a 6, that's where our eyes really struggle to see those objects. They're too dim. Even in dark skies, they get too dim, and you need optics, binoculars, a telescope, to see those. So after this point, we need help. So the Ring Nebula, you would need a telescope to view. And then so on, way out here to the dimmest objects in the universe, so dim in some cases that you can't even see them in visible light. And that's where something like the James Webb Space Telescope comes in, and it can start looking even deeper into space. So faintest objects are in the positives, brightest objects in the negatives. And you will see, as you explore different applications, like one I'll mention soon is stellarium, you'll see this measurement for these objects, this apparent magnitude. And it is a good way to relate objects. Once you start viewing the sky more and more, you'll be able to say, okay, I see how Vega is at a 0, but then something like Jupiter, when it's out, is even brighter. You'll be able to make those comparisons. The reason, though, why this is not intuitive at all, this number line, astronomy is a very old science. And when they first started measuring brightness, it was really about stars. And so they called the brighter stars first magnitude stars. Dimmer stars were second magnitude, third magnitude, fourth magnitude, and down the line. So they were a ranking system. And over time, we've adapted that to our brightness measurements, mostly for consistency. So that's why we end up with this number line the way it is. So not super intuitive, but once you get used to it, you learn to live with it. All right, now finally, C is for coordinates. And there are 2 coordinate systems we're going to talk about today. The first is this one called altitude and azimuth. And this is a really easy system to learn. And you already might know pieces of it or the whole thing. So it's based on your compass directions, and it's based on a basic angular measurement from horizon to zenith. So what we were talking about earlier, your horizon is your true horizon is the 0 marker. That's your 0 degrees. And as you climb up in the sky to zenith, that's your 90 degrees. So that's your altitude part. Your azimuth is going around the compass. So north, due north is 0 degrees. East, 90 degrees. South, 180. And west, 270. And then all the way to 360, and it counts again. Okay, so something like the North Star on this grid, on this coordinate plane. The North Star has an altitude of your altitude. Does anyone know our altitude in our area? Or I should say our latitude, excuse me. 42, yeah. Almost exactly 42 degrees for us here. So our latitude is 42 degrees, and that will be the altitude of the North Star. When we show you the North Star later, use that handy trick to see if you can measure 42 degrees from horizon to where the star is. And then, because it's the North Star, due north, it's going to have an azimuth of 0 degrees. But then if we come around to this other side, to this generic star in the sky, we can measure up from horizon to its point in the sky. That's a 50-degree altitude, and then around on the azimuth to 150 degrees. So this is how we're really trying to coordinate the sky. We're trying to organize it and give it specific coordinates. But there is a problem with this system. It's not temporal, meaning that it doesn't keep up with the rotation of the Earth. So the Earth spins, and this coordinate system does not spin with the Earth. It stays fixed. So as the star field moves across the sky and objects with it, they move through this coordinate plane. So this only works at an instant. No, that's not entirely true. The sky doesn't move super fast to us. So you can give general points over the course of several minutes, and the star or object is not going to move too much. But using telescopes, this kind of coordinate system does not work as well. And we need a system that can better organize the sky and objects in it. Something similar to how we map out the Earth using latitude and longitude. So this is great for an instant in time, and even just for observing on the ground with your eyes. But equatorial coordinates are really handy for telescopes and for giving objects, especially stars, specific coordinates in our star field. So let's piece this together. How does the equatorial system work? So we take our view of the night sky and consider it a sphere around us. This is actually how early models of the universe worked, with a celestial sphere, these shells around Earth. And we now know the universe to be super vast and goes well beyond our planet. But this model still works for this coordinate. We can still use this idea of a celestial sphere, kind of putting all these objects at infinity around us. And we have the Earth right at the center of this celestial sphere. Now we take our equator, so the equator going around the Earth, we project, we send that equator out into space to hit that celestial sphere. So again, taking the equator of Earth and pushing it out to hit the sphere. So they're lined up, they're in the same plane. That's the celestial equator. And when we have that celestial equator, this part's super easy. We can map out in kind of what we would consider latitude for the celestial sphere. We call this declination. So latitude is analogous to declination in this case. So at our equator, that's celestial equator, that's 0 degrees. We can climb up to 15, to 30, to 45, 60, 75. And at the North Pole, we have our zenith at 90 degrees. So the North Pole goes straight up. Okay. And then we take the path of the sun throughout the course of the year. What this means is it's a path of the sun as we orbit around it. And because of that perspective, the sun takes a path through the star field. The sun will not stay within the same grouping of stars. It's going to travel through them. And if you know your zodiac constellations, that's really what defines those. The sun is traveling through the zodiac constellations along this line. And this point is super important. That 0 degree marker is the vernal equinox for us here in the northern hemisphere. That's the spring equinox that happens in March. So that's the starting point. That's what defines the next coordinates of this system. We have our declination that goes up, kind of like latitude, and then we have this right ascension now that's going to go around, and that's analogous to longitude. But we needed a definition for it. We couldn't use the prime meridian of Earth because the prime meridian moves with the Earth. So we needed a space definition to make an analogous longitude. And here it is, the right ascension. And it's measured in hours. Sometimes you'll see it in degrees, but it's usually you'll see it in hours. And don't think about it like time, think about it like just a clock, the hands of a clock, moving around a 24-hour clock. And then within those, you'll have minutes and seconds too, for more granularity. So that's your right ascension grid, going around, and then declination is going up on our celestial sphere. And now we bring everything together. You see that we have the vernal equinox. We move eastward, go around, all 24 hours to get our right ascension, and then climbing up to 90 degrees for our declination. And you can see it goes negative on the other side. All right. So that was giving you the concept of the coordinate systems. And I want to show you a real-world model, a real-world globe of the celestial sphere and right ascension coordinates. So I'll just come around and show you how you can see the star field and the constellations around the Earth. And the Earth's globe in the center. So this is exactly what we saw, but now it's in 3D. Come around on the other side. You can see all of our constellations. And by the way, there are 88 total constellations. And we are focusing on the northern hemisphere today. But we only ever get to see about half or so, a little over half of the constellations in the sky in the northern hemisphere. Lindsay in Australia gets to see the other half in the southern hemisphere. All right. So those are your ABCs. Gives you a map to explore the sky. And there's lots more that you can learn there, but it's a brief overview. Now let's look at Stellarium. Stellarium is your at-home planetarium. And you can download it for just about any device you have. Or you can just use the web version. If you just want to try it out, this is a great place to go. Less features than the downloadable versions, but a good place to start. And we'll go to the current time. You see I just went down here to the right-hand toolbar where you get date and time, and I can go straight to present time. And this is what the sky looks like just about right now. It's kind of overemphasizing the twilight outside, but more or less, this is accurate, at least positionally. And yeah, you're already able to see Mars is out there in the sky. We'll talk more about planets in a bit. But I'm going to get the skies a bit darker here so we can see even more. We're going to skip ahead a full hour. There we go, to 10 p.m. And you can go all sorts of perspectives like with this. If you want to see an all sky view, you can point the camera upwards to see everything, or you can bring it down to see your horizon view, and you can zoom in. I'm just using the scroll wheel to do that. We can organize the sky with our constellations. We can even draw out some artwork so you can see the mythology behind these. And we'll continue to explore this. The other tool I really want to show you here, we'll leave the constellation lines on, but I want to show you, you can practice with Stellarium using the 2 coordinates I just showed you. The azimuth grid is right here. So again, you can see the map out of this grid, 0 degrees up to 90 degrees at zenith, the top of the sky. And then your azimuth going all the way around from 0 degrees north, 180 degrees south, and then back around to north. All right. And then we can turn that grid off, and you can switch to the equatorial grid with our declination going up across the sky, and then our right ascension going across. And if you look north, this star right here is Polaris, the North Star. And you'll find the North Star at the very top of your equatorial grid. And that should make sense, right? Like we talked about before, this axis, this axis here of our globe, that's the top of our declination, your 90-degree marker, and the north pole of the Earth is going to point right into that. And it just so happens that on our celestial sphere, what star is there? Polaris. So that's why we have a North Star at all. If you look at the southern hemisphere, there is no South Star, at least right now. And we won't always have a North Star that points due north. We happen to look out right now. But that changes beyond a human lifetime. All right. There's my thing. So that's a good start to Stellarium. We'll talk more about it too. All right. Again, that's all free too. There's a free app version in the App Store. There's lots of ways to access Stellarium. So what can we see in the sky this spring? Lots to see. I always like to start small and go bigger in the universe. So we'll start with the International Space Station. That's really close to us. And this space station is the size of a football field. It's massive, and most of that size certainly is taken up by the solar arrays of the space station. And then through here, these are the living modules of the ISS. And it's been in space now for decades. And unfortunately, it is coming to the end of its life. So only a few years before the space station will have to come down in a controlled way. Don't worry, it's not going to crash into your house. But they will have to bring it down, and the hope is that there will be successors. Right now, the plan is probably through private industry to get successors to the ISS in orbit. But the ISS orbits just under 250 miles above the Earth. And it orbits once every 90 minutes at a rate of 17,500 miles per hour. So it's zooming once around the Earth every 90 minutes. And at that speed, you can travel to New York, to Los Angeles in less than 9 minutes. So the astronauts on board the International Space Station have an amazing perspective on the Earth. And you can hear all sorts of stories from them that explain that. And of course, there's nothing like seeing it, but we can get a sense of that perspective from there. I recently heard some particular stories from them around the pandemic. Like those were really profound in specific. For them to just know what's going on, but not being able to fully see what's happening down on Earth. All right, the ISS flyovers coming up. You can look these flyovers up on a website called Heavens Above, and other Stellarium will show you too, but Heavens Above gives you a really nice table view of all the upcoming flyovers. I'll show you it in a second, but this is a brief view of that table for the coming flyovers, and they're not ideal right now, but in the next couple weeks, we'll be back to more evening flyovers rather than early morning. So June 21st, we have, you see these all are in the negative. So these are, especially these two, in the realm of Jupiter's magnitude. So these are really bright, very easy to spot with the eye. And I'm going to emphasize this one here. If you do happen to wake up early, it's almost a -4 magnitude. Again, super bright, similar to Jupiter and Venus. It starts at 4:44 in the morning at the southwest at an altitude of 10 degrees. That's a fist, right? Above the horizon. And then highest point is 4:48 in the morning. This is what's cool though. I don't think I've seen one like this yet. It's at an altitude at zenith, 90 degrees up. So that's at the highest point of the skies. That would be really cool. I don't know if I'm going to wake up for it, but we'll see. And then 4:51. Oh, is it going to? Okay, well then there's my answer. I get to sleep in. 4:51 in the morning, northeast at an altitude of 10 degrees is where it ends. Okay, so look out for ones like this. Even ones like this one here where it gets 51 degrees, still really cool to see. And what does it look like? Like that. It just looks like a moving star, more or less, across the sky. But even though that's what you see, it's something very close to home compared to other objects out there in the sky, and there's people aboard, which we're about to learn about here. There's a great website that you can go to called whoisinspace.com. And right off the top, it tells you there how many humans are in space right now. So there's 13. And if we scroll down, you can go through each mission and each flight that went up to either the International Space Station or the Chinese Space Station. So this was the SpaceX Crew 10 mission. You see a couple of NASA astronauts, a cosmonaut from Russia, and from JAXA, the Japanese Space Agency. And then aboard the Soyuz mission, this is a couple of cosmonauts and an American astronaut. That is the partnership the United States and Russia has had throughout the duration of the space station's life. So you send a NASA astronaut aboard Soyuz and a cosmonaut aboard the American space missions. And then we have astronauts on the Chinese space station. 3 on the Shenzhou 19, and 3 more. It's possible they might be crossing paths right now. I'm not 100% certain. Usually I only see 3 here, but there's 6 on board that space station at the moment. So yeah, at any time, there's also the Axios mission go up yet, Drew? Or is it?
22nd.
The 22nd.
As early as the 22nd.
As early as 22nd. So this list might get bumped up a bit because there's a private space flight to the International Space Station. So you might see that number rise. It's a short duration flight, but space station will be a little packed for a moment there. All right. Oh, in Heavens Above, you put your location here, and then you can come down to any of these satellites, including the ISS, and it gives you this nice table view, and you can skip ahead. It is limited because the ISS will make corrections to its trajectory over time, but you can usually get a couple weeks into the future and really see where it's going to be and how bright it'll be. All right. The solar system. So let's see what's out there. I always start with the sun because it is observable at a place like Kopernik. You never want to stare at the sun with just your eyes, right? If you have eclipse glasses still, and they're not damaged in any way, no pinholes, no scratches, you can still view the sun with those. It doesn't have to be an eclipse. And sometimes if there's big enough sunspots, these big magnetic storms in the sun, you can see those. There was one in particular last year that you could really notice with just your eye. It was massive. So you can use those eclipse glasses as long as they're in good condition. But otherwise, come to a place like Kopernik sometime, and you can observe the sun using our solar filtered telescopes. Otherwise, don't even try without the right equipment. We are it sounds like we're just getting out of solar maximum. The thought is that it was probably peak solar activity was sometime between August and November of 2024, based on the current data, but we won't know for sure until we're maybe a year out to see how that spike went. The sun goes on an 11-year cycle of peak activity and low activity. And did anyone get to see the northern lights last year, especially, or even recently? So during solar maximum, these storms on the sun, these sunspots, can throw off major coronal mass ejections. That's a whole bunch of solar radiation and material and particles launching from the sun, and sometimes they launch towards Earth. When they do that, we can get northern lights this far south. And we did get those almost a year ago. This was from August 12th of 2024. We got to see our first major northern lights display. May of that year, there was also another opportunity, but sadly, it was cloudy here. There was another chance at Kopernik to see them on October 10th, I think it was. And that was an even stronger display than what you're seeing here. We did do a live stream on that if you want to see what that looked like on our YouTube channel. But what's kind of neat about this day is that there's all these weird things flying over the observatory you see there. That's not normal. You usually don't see that. Like we won't see it tonight. But what we believe those to be is there was a report of a rocket that had exploded in the upper atmosphere. And that was most likely either little pieces in orbit or coming down into the atmosphere. So they're chaotic. You can see how they're zigzagging and all over the place. So not something you would normally see in the sky. But kind of a neat effect that day. There was a lot going on in addition to the beautiful, colorful display of the northern lights. Now, it's totally possible that we'll see them again. And I'm going to show you a resource here called spaceweather.com that does a really good job of tracking the sun's activity. And right at the top of their site, when you go here, they'll report any chance of flare and northern lights activity. And as you scroll through the page, you'll also be greeted to a data set like this, where you can see, if you click more data, this chart here shows you the solar activity as it comes from Earth's perspective. So there's this measurement called KP index, which corresponds to these geomagnetic storms that are responsible for northern lights. So this is enough activity that if you were up north and the skies were clear towards the North Pole, you'd be getting something. There's enough activity there. But for us, we need to get up here into a KP7, a G3 storm, or even better, an 8 or 9. And for those storms, they would be directly overhead for us, kind of like what we saw in that video before. So yeah, look out for when it goes orange or red on this page, because that is when there is a chance. I think back in May, there was another opportunity, but again, cloudy. So that's something we have to work around for us in Binghamton, but hopefully we'll have another go. It's not like the sun's activity immediately drops off either once it hits peak. It's a wave, so it's going to come down gradually. All right. Perfect. The moon, of course. You can't, we have a mixed relationship with the moon. It is a great object to observe when it's out. It's a great target, especially if you have a telescope at home. Great first target is to look at the moon, because it's easy to spot in the sky, easy to get your telescope to it, and easy to focus as well, and get a sense of just how your telescope works. But after a while, at an observatory, the moon starts to get in the way more often than it's helpful. So yeah, that's where that mixed relationship comes in. But it is extraordinary to observe because of how much detail you can see. And one lunar cycle plays out over 29 and a half days. So that's when you'll go from starting at the top of the lunar cycle, new moon, to first quarter moon, which is your first half moon. Then you go to your full moon, third quarter moon, your second half moon, and then back to new moon. That's that lunar cycle. And of course, how do you observe it? Totally safe to look with your eyes. That is sunlight bouncing off of the moon, but it's not harmful in any way. In a dark sky area like ours, if you look at the moon without a moon filter in our telescope, you'll notice you kind of lose your night vision in one eye versus the other. But it's not damaging your eye. It's just very bright compared to the darkness around you. And you can view with unaided eye binoculars, telescopes, or cameras, of course. And nowadays with your phone, if you have a telephoto lens on your phone's camera stack, you can usually get a decent picture out of the moon. It's always worth a try. We'll talk more about that too. The total lunar eclipse. I did want to review this because we did a preview of this event in our Spring Skies program. And now, of course post-event, we can share with you an image from the total lunar eclipse. And it's from March 13th to the 14th of 2025. What I can do is I can hop to our YouTube channel and show you the time lapse right here of that event. And I can show you an ad. Okay, turn the volume back on. So this was taken with our C-STAR telescope. It's actually a telescope that's only this big, but it does tremendous work at keeping your object in center, and it's both camera and telescope. So it collects great data. We start with that partial eclipse, the moon going into the Earth's shadow, and I switched exposures there so that you can see the red that comes with a lunar eclipse. And this is the totality part. The moon's fully in the Earth's shadow there, your red or blood moon, as it's known. And that red color comes from the Earth's atmosphere. What color is the sky during sunset or sunrise? Red, kind of red, pink, maybe some orange hues. A lunar eclipse is, I'll go back here to that. A lunar eclipse, a total lunar eclipse like this, is as if every sunset and sunrise on Earth is projected onto the moon all at once. So if you're on the moon viewing this event as a solar eclipse, you will see this kind of red ring around the Earth because you're seeing all the sunsets and sunrises happening at once. So that's why it turns this red color. There's a lot of indirect light at play there. All right. Now we're on to planets. And for those night owls or early birds out there, you won't have too much trouble, but for those that go to bed at reasonable hours, Mars is really the option here. Early evening, we will be able to spot Mars. It'll be one of our targets tonight. This is a picture taken through our 6-inch telescope at Kopernik during Mars opposition. That's when it's best viewed through telescopes. So that was back in January for us, was Mars opposition. So when you have that close approach, you get to see things like the ice caps and even some geological features, like this one up here is called Syrtis Major. But as Mars moves away, it does get smaller and smaller in the sky, and we get to see less and less of what's going on the surface. And that's kind of where we're at right now. Not quite at the furthest point, but it's far enough away that it's going to be a little challenging to see a lot. But we'll do our best. We'll see how much we can push it tonight with our magnification. So this is your PM object, early evening. Visible planets in the AM, though, you have more options if you're an early bird. We have Venus, Saturn, and Jupiter. And these also were all taken at Kopernik. This was during a very thin crescent phase of Venus, which is among the cooler things to see about it, is Venus will go through phases like the moon. So that is a crescent Venus. Saturn is interesting right now too. This picture was taken back in the fall, but it's pretty similar right now where the rings of Saturn are really close to edge on. So you're not seeing too much of the top or bottom. You're seeing them closer to the edge. And back in March, they actually disappeared completely. When the rings are so thin that when you look down the edge, they're just gone. So we're kind of at that point now where the rings look very thin. There's not a lot of form to them. And then we have Jupiter. And with Jupiter, you can see things like the Great Red Spot. That's the big hurricane system that's larger than the Earth happening on Jupiter. It's been happening for hundreds of years at least. And then over here, we have a transit of one of Jupiter's moons. I believe that one was Io. And when you see Io transiting, you can see the moon in front, but also the shadow, a solar eclipse happening on Jupiter. So we can take a quick look at those planets in Stellarium. Yeah, we're doing okay on time. So we found Mars before, and one really cool thing you can do in Stellarium that I haven't shown you yet is you can click on an object like Mars. We can center, and we can zoom in like a telescope. And there you have it. There's Mars up close. And it does show you in Stellarium, Deimos and Phobos, those two moons of Mars. They're very tiny, though, very hard to spot. You'd need I have never seen them through a telescope because they're just little captured asteroids. But Stellarium at least shows you where they are. All right, so we'll zoom out. And we'll go to the morning hours next. Look to the eastern sky, and you see Saturn comes up first. If we skip ahead a little further, we get Venus. And then we're not quite getting Jupiter this month yet. I think we have to skip ahead to July. Yeah, there's Jupiter coming up just before sunrise in July. And this gives you a sense, too, of how these planets move over time through the star field. Planet directly translates to wandering star. So they don't keep up with the celestial sphere. They run through it and run through the star field. So if we skip ahead, you'll see Jupiter. Let's go another month into August. Jupiter actually gets past Venus, or rather Venus moves further through the sky towards the sun as it goes around and swings around. So now Jupiter is in between Venus and Saturn. And as we get towards fall, get closer to fall, Saturn will become an evening object instead. And then into late fall and winter, you'll see Jupiter do the same thing. So, little light on planets for the evening hours, but they are out there in the early morning this summer. Okay, go back here. All right, Perseid meteor shower. This is a major event each summer, each August. And the predicted peak this year, and very often it ends up around these dates, August 12th through the 13th. And we expect a meteor rate of about 60 per hour. This was a Perseid meteor. The constellation Perseus is right in here. And this is a Perseid meteor in the sky flying above the Andromeda galaxy at Kopernik. So you can see it has a green color. That's pretty common for Perseid meteors. They'll take on a green color. Very easy to pick up that green in a camera. You will just about see it with your eye, especially if it's a bright one. But the idea of a Perseid meteor is that they appear to come from the constellation Perseus. You can always trace them back. This one's shooting across the sky in this direction, up into the corner here. And you can trace its origin back to the constellation Perseus. And the reason for that is because comet, I believe it was Comet Swift-Tuttle, came through into the Earth's orbital plane and left behind all of this dust and all this stuff. And we run through that dust field every single year. And it just so happens that on our celestial sphere, the Earth is running towards Perseus. And that's where the impact kind of appears, where you'll get all that material originating from. They don't always hang out super close to Perseus. You will see them further across the sky. But the idea is you'll be able to trace them back to that constellation. That's their radiant point. Oh, I thought I did. But yeah, the Andromeda is here again, and we'll talk more about Andromeda in our deep sky objects. But yeah, that is pretty close to maybe not the core being as bright, but the fuzziness of that object not too far off from what you'd see with your eye. It would look like this fuzzy star in the sky. All right. So I think I have one more picture. Oh, so Perseid meteor shower last year. Remember I mentioned that was August 12th, that we had the Northern Lights? Couldn't ask for a better set of events. We had these weird things flying through the sky that looked cool. They weren't, they're human-made, not supposed to be there, but they looked neat. And then you had the Perseid meteor shower, so that's a Perseid meteor there flying through the sky. And you had the beautiful, colorful display of the Northern Lights. So I'm not sure we'll ever be able to top that night, but it was so cool to see all those play out. I want to show you why this year is a little tricky with the Perseid meteor showers. And this goes to show too how powerful stellarium is, because we can just bounce around wherever we need to go. We can go to August 12th that evening. I'm going to back this clock up. It's 12th into the 13th, so we'll just put it at the 13th at around 1:30. And here we go, looking to the east. Here's the constellation Perseus. That's the radiant point. If we zoom in a little, does anyone see a problem with this night, though? This right here is our problem. The moon is not a crescent moon. And it wouldn't be at its location in the sky there. It's a gibbous moon. And that means it's going to be pretty bright out at that time, even during peak. But that means any time kind of before or after moonrise and set, that's going to be the time to try and catch these meteors. The brighter ones will still break through the moonlight, but it definitely poses a challenge for viewing Perseid meteors. You won't see the super dim ones when when it's out like that. The nice thing, though, is the Perseid meteor shower goes from July 24th, July 17th, and then to August 24th. So you have a wide range to catch Perseid meteors outside of that moonlight. So just find a dark sky area on a good night, and the way this year has been behaving, just find a clear night, and that's what we can hope for. All right. We're getting towards the end here, but just a few more things. Moving into the star field, going beyond the solar system, we have the Milky Way, and we've talked about that a couple times, but the Milky Way is our galaxy. It's the one our solar system, the sun, and billions of other solar systems reside in. And because we're inside this galaxy, we don't get to see the entire thing. And we certainly haven't achieved grand enough interstellar travel to take a picture from the outside of it. So what we see is this band of stars, dust lanes, like these darker parts. It's a star cloud across the sky. And in the summertime, for our location, the brightest part of the Milky Way gets above our southern horizon. That's what this picture was taken at Kopernik a couple years ago. And again, out that way is super dark. That's the darkest part of our sky because there's no city lights out that way. So we get to see views of the Milky Way like this. And if it stays clear tonight, we may just about be able to see it start rising above the eastern sky. And then as the summer goes on, it'll rise earlier and earlier, giving you more chance to see it in the early evening. And again, just talking about meteors, there is a little meteor flying through the Milky Way there in this image. But this is the core of the galaxy. And then as you go further out, you get to the edge of the galaxy across the sky. Here's another view of the Milky Way right over here. The core is just below the tree line there in this image. And we're looking out towards the kind of middle section of the Milky Way here. And over here again, a meteor. And this picture has a comet too. This picture is actually from the fall. It was October of last year. But it goes to show the chance to see the Milky Way will continue. This was very early in the evening at this point, so the core has dropped below the horizon in October, kind of showing you the path that this star field takes over time, over the coming months. But midsummer, one of the better times to observe the Milky Way at a convenient hour. All right, deep sky objects. These are objects that can be in our galaxy, but they can also be beyond our galaxy. And we're not talking solar system objects here at all. So here are some examples. The Whirlpool galaxy, right near the Big Dipper, the tail of the Big Dipper. And all of these images I'm going to show you were taken here at Kopernik through various telescopes. I believe this one was through the 20-inch, our largest scope. And this shows you the top view of a galaxy. So this is what the Milky Way kind of looks like. It's a spiral galaxy. We know that from the structure we can see from Earth. But you can see these beautiful spiral arms in this whirlpool. And what's really neat about this structure is that there is a second galaxy right here. And do you see all this fuzziness around the galaxy, especially the smaller one? That's all these stars and gases being thrown off as these two galaxies collide, and eventually they'll merge over billions of years. Their cores will merge. But right now, this is a collision in action. You can't see it move because these are objects, massive objects, billions of stars in here. So you can't see them move live, but we know they're colliding based on all these observations you can make. And this is the fate, eventually, of the Milky Way and Andromeda. We'll end up in this same situation. Billions of years from now in the future, Andromeda will start colliding with the Milky Way. Here's the Pinwheel Galaxy, again through our 20-inch, and this was taken back in 2023 when a supernova went off in this galaxy. We have that labeled here. So we were able to actually see that star, not really visible anymore, because supernova are these explosions of stars in space. So they are relatively brief from other events that happen, and we were able to see this star brighten up and dim down. So a supernova, galaxies like this are the best place to hunt for supernova because you have this vast star field to observe and just watch billions and billions of stars at one time. Gives you a great chance to spot one. So astronomers are always looking for things like this. Andromeda Galaxy. This is the closest galaxy to the Milky Way. And it's, I haven't mentioned these catalog numbers. M31, you'll see various numbers. That's a catalog that was formulated by an astronomer named Charles Messier. And for this catalog was basically his not comet catalog for other astronomers to use, so that when across the world someone says, I've spotted something, it looks like it's a comet, he will tell you it is not a comet. So that was his catalog to tell other astronomers, not a comet. Something may be interesting, but we don't know what it is. And eventually we found out, I mean, comets are great. They're great to see in the sky. It doesn't really compare to an object that has trillions of comets in it, plus all these other things happening like stars, solar systems, and planets. So it's kind of fascinating, just that growth of astronomy, right? How we learn more. These objects in this catalog are amazing, very fascinating to learn about. Here's another section. These two are in the Milky Way, the Trifid Nebula, M20, and the Lagoon Nebula, M8. So here's Trifid over here, and the Lagoon over here. These are star-forming nebulae. That means stars are born here. The gas and dust is condensed enough that over time you get these clusters forming, and eventually you get stars igniting through this process of fusion. Hydrogen smashing into each other to form helium. So these are spots in space where stars are born, and they're right in the Milky Way. In fact, in the background image, you can just about see them, or at least the influence of them, in that region of the Milky Way. So these are great. There's all sorts of these. If you look across the Milky Way with binoculars or a telescope and just track through it, you'll see so much going on because of how dense all that matter is. Here's a zoomed-in view of the Trifid Nebula. Gives us a great example, too, of emission nebula. The pink there is glowing. It's actually glowing gases and dust from stars in energy forming. And then on the other side, you have this blue color. That's reflectance nebula. That's starlight reflecting off of these clouds. So no glow there, just starlight reflectance. So that's a good way to remember. The pink is the emission, the blue is the reflectance. Here's the dumbbell nebula, M27. And this is different. This is not where a star is being born or where stars are being born. This is where a star has died. And is a good example of what our sun will do one day. Billions of years from now, our star system will end up a planetary nebula like this. The reason they're called planetary is because through a telescope, they kind of take on the shape, so this circular shape of a planet. Astronomers knew it wasn't a planet, but it had that shape, that circular shape that you'd expect. If you look right at the center here, right there above the red dot, that is the remaining white dwarf star at the center, what remains of that star. Everything else blew the outer gases off, and just that white dwarf remains as it slowly cools down over time. You'll see other, like supernova remnants are very different from this. There's a lot more going on. Like right over there in our room is Cassiopeia A, which is a supernova remnant. those are the grander. For bigger and more massive stars, that's what they can look like. But this is for smaller stars like our sun. All right. We are winding down here, so I'm going to skip that stuff, but you can do a search in Stellarium for any of those objects that we looked at to see where they are. Last thing we're wrapping up with are some tools that you can use at home or wherever you are, out and about. Stellarium, you can get it at stellarium.org, the web version or any of the downloadable versions for Windows, Mac, Linux, all sorts of options. But there's other stargazing apps too. Some of these I like to use more than Stellarium on my phone. So these are some great options. Starwalk and SkyGuide are more or less two versions of the same thing. They operate very similarly. It's just kind of choosing what format you prefer. They both have their own kind of news or announcement notifications, so you may have a preference there. You can try it out. There's free versions for each of those, and then there are, like many things today, there are pro features that you can pay a subscription for. But they're great even just at their baseline free version. And then if you want something more advanced, that's where Sky Safari comes in. It's a great tool for your phone. It does everything these applications do, but it also brings in more features like telescope operation. If you have a compatible telescope, you can use Sky Safari to control it, to find objects, to go to objects. It's a really powerful tool. I also really like it for astrophotography because you can put in your different equipment and it will show you the field of view for that equipment in the sky. And that's really helpful. So if I'm trying to piece together, okay, I want to look at Andromeda, I need something that can take a wide field image. And if I put my equipment in, it will show me the box for the field of view. My camera will take the picture. So lots of powerful tools to use in Sky Safari. And of course, your smartphone. This is why I always recommend trying, and you can try it tonight too. A lot of smartphones over the last few years have come out with a feature called night mode. And night mode allows you to, even handheld, take long exposures of the sky to get an image. And that's an example on the left-hand side here. Whoops, hang on, this one here. That's a night mode shot from inside our 6-inch telescope looking out through the dome window at the total lunar eclipse in March. So there's the lunar eclipse happening right there, and you're picking up stars around the moon too, which would be really challenging to do if there wasn't a total eclipse. But it was a great opportunity to take this night shot. And again, handheld. I did not have this on a tripod at the time. I did kind of rest it against the telescope, and I took a 10-second exposure of the sky. Then on the right side, this is where I used a little bit of an optical assist. And by little bit, I mean I had my phone hooked up to this telescope. But that's not something you can totally do that too. If you have a telescope at home, you can use an adapter to put your camera on and take a picture of the sky, long exposure on night mode or otherwise. So it's great opportunity to use for getting better pictures of the moon using that method. And I'm not sure, are we going to have that set up tonight, Drew, by chance? The CA.
Oh, I can ask for that to happen.
Okay, yeah. If you want to try that, try in a telescope smartphone adapter and take some pictures of the sky, we'll try and work that out for you tonight. We have a special telescope for that we can target Mars, we can target some of these deep sky objects, and we can show you how that process works, if you like. And then you have a nice picture to go home with. All right, so those are some examples of what you can do with your phone. And for once, at least from over the last year, what I can remember, I get to actually say clear skies. So thank you so much for tuning into our talk here. I'm definitely happy to take any questions. If we have any on the live stream, that's great too.
Yeah, we do. There's at least one, or at least comment, but any questions here? I bring this mic around so that the people on the live stream can hear. Oh, a question back here. Hold on one.
I don't know if it's a dumb question or not, but when you showed the dumbbell nebula, you said it was a dead star. So why was the coloring blue if it was cooling down?
Okay, so those gases there, it's a different chemistry going on for a star that's died. The reason the emission nebula of something like Trifid is pink is because that's hydrogen. When it's energized, it emits a pink color. But there are all sorts of, I can even go back to that picture. If we go back here, where is it? Here it is. In the case of the Dumbbell Nebula, the glow that you're seeing it's different elements, different compounds that you'll find the star has given off. And it's examples like this that show you why we have higher elements in the universe at all. At the start, it was only that pink color, that emission nebula from the hydrogen. But as stars die, they've been burning more and higher elements to survive, basically. But eventually that process fails, and the energy and the expansion of the star grows, and it leaves behind higher elements. And that's why these colors are different. It's not hydrogen we're seeing there. Probably some oxygen, I want to say off the top of my head if I remember my color chemistry right. But yeah, that's why it's not just pink there. It's a great question. Yeah.
If I could interject, actually, if you would look at the Dumbbell Nebula tonight or whenever, you would never see that blue. It would just look like a white blob. And so this is a time exposure. I don't know exactly how long of an exposure.
Probably a stack, and it was like 30 seconds each stack. I'm not exactly
Right.
sure. But yeah, that's a great point too, is a lot of these images, the cameras are going to do a lot better than your eyes looking at a single instance in time. Cameras have the advantage of collecting light over time to give you more detail. It's still visible light, but more light collected.
All right, let's see here. Actually, Lindsay from Adelaide, Australia said that she grew up in Wisconsin and Illinois and was excited to see the Orion's Belt in summer, but now that she's at 35 degrees of south latitude in Australia, she sees Orion's Belt all year round.
Oh, that's cool. Oh, that's really nice.
And another person, Wagon Load, says, if your phone or tablet has a real compass, Google Sky Map shows you the star your phone is pointing at. So that's another option.
Yeah, for Google Sky Maps, for Stellarium, for any of these handheld smartphone apps, as long as your phone has a compass in it, you raise it up, and it will do its best to sync up with the sky based on the compass direction. It's not always perfect, but it usually can get you in the right realm for you to start piecing together constellations.
Any other questions? Oh, another one over here.
I'm changing the subject, but do you guys think that the James Webb Telescope, when it starts to focus, it's supposed to focus I've read someplace it's going to focus on Alpha Centauri A and B, and it's going to try to see if there's a planet there. Because there's been some dust that fooled people, thinking there was a planet about the size of Neptune possibly in there. But I guess the binary system destroys planets too because of the gravitation and all that.
Yeah.
I mean, do you think it's possible that there's a planet there? Because we know there's one around Proxima Centauri, but of course it's a dwarf star, and the planet's fairly close, and it's like Mercury. There's no chance of life, or minimal chance of life ever being there.
Yeah, that's a really good question. I'm not certain. I will say, at least in regards to James Webb, its whole mission certainly is to teach us new things. And I have heard the idea that binary star systems, there's the gravity at play there. It would be really challenging for some planets to survive in that environment. But yeah, we'll see. We'll see what James Webb can show us.
Any other questions? Oh, another one back here. Okay, good.
How do the constellations make those like shapes?
Oh yeah, we didn't have too much time to talk about constellations, but I will show you the idea, and it actually brings us back to our talk on brightness and magnitude. So if we think about constellations, and this could be a whole talk in itself, like there's mythology here, lots of perspective we could talk about, but I turned off the constellations, and Stellarium does a decent job at showing you the brightness of stars compared to each other, just visually. And if we look down here, where are we? Oh, we're in August. Let's go to our current star field. And like, that's Taurus the Bull, and that's a little, not out right now, but let's look over here at some familiar ones. So this is pointing the sky north, and I bet your brain is already putting pieces together. It's already connecting these dots naturally. And they might not be the perfect constellations, but guess what? That's okay. Because, you know, we just decided that these are the constellations. The 88 that I talked about on the celestial sphere, we had to designate the sky somehow and organize it somehow. But it's not like you can't tell your own stories in the sky. That's exactly what humans did to start with all the Greek and Roman mythology. Every single culture throughout human history has looked up and told stories with the sky. And if you look here, what is that? The Dipper. That's the Big Dipper, right? You don't even need the lines because you can see it, and that's what we'll do tonight too. You're going to have to use your imagination to piece these together. So that's the Big Dipper there. Down here, what does that look like? A couple of triangles, a W, exactly. That is Cassiopeia. Kind of a zigzag or W in the sky. So that's exactly right. Tricky one, though. Constellations work best when they're made up of stars of similar brightness. I'm pointing here. Do you see a constellation there? Let's turn the lines on. That is the Little Dipper. It is made up of really dim stars. The brightest one is Polaris, the North Star. But everything in between is so dim, it's really hard to piece together. But if the skies are clear enough tonight, we'll show you how you can do that and some tricks as well to find Polaris without seeing the Little Dipper at all. All right. Any other questions?
Oh, another question, I'm sorry? All right. If you allow me, actually, one of the things that whenever we have school groups come up here, we do, and it's sunny out, we have given an opportunity to actually look at the sun through one of our telescopes. And Jenny had mentioned that, you know, you shouldn't look at the sun yourself, you know, but if you have those solar eclipse glasses, you know, yeah, it's safe to look that, but the problem is you can only use those glasses by themselves. Unfortunately, the people on well, I'll take it up to the live stream so you can see it. But this is what happens when you put eclipse glasses behind binoculars. Do you see those little holes? That took less than a second to burn through. Actually, as we were preparing for the solar eclipse last year, Jenny and I set up a pair of binoculars and basically covered the front end of it, stuck these glasses behind, and basically took my hand and just did 1001 and then covered it back up again. It took less than a second to burn through that film, so don't do this in a word or in a phrase. So I don't know if there's any other questions or anything else.
It doesn't look like it.
All right, so you guys picked the best night to come, the best night we've had in 29 weeks, I think. So we do have scopes open. We also are setting up that EAA, the electronically assisted, the C-Star, will also be out there. And Doc Carter will be out there with his mega laser. to do a star tour. Jenny will be there as well, and we invite you. In fact, the rule here is you can't leave until you look through the telescope. So just leave your keys here, and you can pick them up after you show proof that you've done that. So to sort of continue our series of talking about astronomy, next week is what we call the Great Telescope Dust-Off. I know a bunch of you have telescopes, maybe even binoculars or whatever, at home, and maybe they're sitting in the garage or the attic or the basement, and it's been a while since you've used them. We invite you to bring those, bring all the parts up. We'll have members of the Kopernik Astronomical Society here to help you put it together, make sure that it's operating, and we'll put our order in for some more clear skies so that you can use your scope to look at the night sky. So I invite you to come by and do that. For those watching on the live stream, that will not be live streamed because I don't think you really want to watch people cleaning other people's scopes. But and then the weekend after that, it was July 4th, and if it's clear, we'll just do a casual night of observing. And then we've got some additional speakers were being lined up. We're just sort of finalizing the schedule throughout July and August. So thank you again for coming up. It was great to see you, and we'd love to see you out in the scopes. And thanks, Jenny, again for a great talk.